Hello, welcome to everyone in this video. This is lecture number 15 on digital electronics. Today I want to discuss about the data conversion, that is the digital to analog and analog to digital conversion. In digital to analog there is a ladder and weighted resistance. Okay, so let's start. You can see this is the total syllabus, that is we already covered the integrated circuit, then number system, then digital circuit, then implementation of different circuit, then data processing circuit, then sequential circuit, register and counter, and lastly computerization we discussed. Today I want to cover the data conversion, and along with the we will cover the all the syllabus of this portion. Okay, so let's start. Analog to digital and digital to conversion. Actually, data conversion is the process by transferring data from one format to another format. This format be analog to digital or digital to analog. When you see there is an analog circuit, that is continuous value, and there is analog to digital converter is converts in analog to digital format. Okay, so analog is the continuous format and digital is the 10 state format, like that. And the reverse digital to analog conversion will be like that. Digital signal converted into the analog signal. Okay, for example, you when you talk in the mobile, you can see your voice is converted into digital format, and which will be transmitted from the network tower and so on. So this is the device where the analog signal converted into digital format. So this is the analog to digital conversion. And in the reverse, when you listen something from this mobile, that is your friends talk to it with you mobile by mobile, you can see the speaker which speak the voice which are analog, but it transform into digital format. So there is a digital to analog transformation. So analog to digital and digital to analog transformation is very important. You can see there is needed latent here, that is the when this signal, if you wants to transmit the analog signal from one point to another point, large distance point, then there is a huge number of distortion and noise are accumulated with this signal. So to avoid this signal accumulation, or to avoid this signal distortion and noise, we just convert it into the digital format, and then digital format can be transmitted, and then just reverse process digital to analog conversion. So there is much important for the digital to analog and analog to digital conversion. Here the important things is resolution power. That is actually this is analog signal and sampling that point, how much you will be resoluted, that minimum value which you can measure, and then quantize, that is the digital format, right? So this analog can be converted into digital format like that in signal. So resolution is nothing but Vrx by V mean by 2 to the power number of bits you wants to it's accumulated. So this is the resolution, that is which minimum value we can measure. There are two types, digital to analog conversion: weighted register and radar. You can see this is the circuit symbol of weighted register. You know this is the op amp, and this is the least significant bit, and this is the most significant bit, and these registers are taken as like that. And you know just using this the function of the op amp, that is the virtual ground, this voltage at this point is 0. So this current addition, you will be get this total current of the circuit. So finally you will be obtain this expression, output expression. Okay, I think you can do this output expression like that. If you know about the op amp circuit, I think you can do this. If there is any problem to get this output formula, you must cover in the comment box. So just put this value, and Rf equals to R, and Ra, Rb, Rc are like that. There is 4 register, so will be obtained. So you'll be get the output voltage expression like that. And if you put this value ABCD is like that, you will be get different analog value. Okay, so ABCD are the digital value which are converted into the analog value. So this digital format converted into analog format, and this is the weighted register digital to analog converter. there are some drawback. You can see the registers are the multiple of this register, so you can take the double, that is the multiple of two register, and this is the very difficult to obtain this multipled register exactly. This is a very um problematic, and here you can see the register is very low value, so mostly current flow through this one, and this is the double, so increasing the resistance current will be reduced. So there is flow huge current, so you need to consider the power of this register as well. Okay, so and the temperature effectives of the register also affected. So these are the drawback of this weighted register digital to analog converter. And another digital to analog converter is the R to R ladder system. That is, you can see this is the circuit, that is 2R, 2R, R, 2R, R, 2R, R, 2R, and connected with the op amp. This is most significant, this is less significant. For example, if you take this ABCD as like that, so this is 1 and this two are 0, so these are 0 means these are grounded. Now you can see these two are parallel, so 2R parallel means R series, that is 2R parallel means R series is the 2R parallel means R series is 2R. So this is 2R and this is 2R and this is V in. So what is the value of V in? The current will be like that, so voltage into effective resistance at this point is like that. Okay, or you can see voltage equals to IR. I think you can do this using Kirchhoff's law. Okay, so using Kirchhoff's law, you will be get this that is the due to this signal. This is V by 2, V in effective voltage, that is V by 2. Similarly, if you take one here, you can see this zeros. So this R 2R, R 2R. So this is 2R 2R. So voltage at that point is V by 2, and since at that point V by 2, so you'll be get V in is like that, V by 4. Similarly, for at that point this is V by 8, V by 16. So finally total voltage will be like that, V by 2, V by 4, V by 18, V by 16. So the output signal will be like that, and if you put this value of this type of binary digital, you will be get this type of analog value. So this is the digital to analog ladder system, and here is the overcome the drawback, that is it is easier because there are two types of register used here. Okay, so this is easier to find, and here you can any number of combination you can arranged here, and there is no such problem, that is the huge current flow through one register is not like that. So these are the uh, comparatively better than the weighted register. Okay, so that's it. That is the digital to analog converter, and the reverse one in the analog to digital converter. Here the analog input is inputted with this comparator, you know, the comparator in the uh, op amp. So you just know about the op amp in detail. The previous semester I think you completed the op amp. So just comparator using, and this is binary counter, so digit output binary output. So this is the analog signal converted into binary outputs like that, and there is another time, that is simulator type. This analog signal inputted here, that is a binary, that is a digital output here. So I just go to your just idea of this circuit here. Okay, so that's it for today. In the next class we will be discuss about the nano and communication electronics. So thanks for